So in this question, I want us to check some basics of our AC theory. Remember, we had this from our N3, working with parallel circuits. But in this case, only that we are trying by all means to apply our complex notation. That is the major part of our N5. We are no longer working those basics that we had where we used to write the total current, which is equal to the square root of IR squared plus IL squared. We are no longer having these formulas. Okay, those were just our basics from our N3. In this case, we are representing everything in complex notation. That's why we had the introduction of our complex notation. So they were given in the parallel RL circuit shown in Fig 1.5, which is our Fig 1.5 here. Calculate the following in polar form. Take note, they've stated in polar form. Whatever that you're going to have must be in polar form. Number one, the circuit impedance, which is ZT, the total. This is the total impedance of our circuit, okay? This is our circuit that you're given there. And we need to calculate the total impedance, and everything that is to be calculated in this case must be in polar form as per our instruction. All right, we do understand from our formulas, and also you are given this from your formula sheet, guys, that we can calculate the total impedance given the reactances, because this is a parallel circuit that we are given. So what we need are the reactances. This is a purely inductive circuit, where we do understand that from our N4, remember, a purely inductive circuit, you were writing Z, which can be written in rectangular form, or which can be written in our like in polar form. We've got two ways, rectangular and polar. So if you had to write this, our Z will be representing the value of our XL, okay, which is JXL. It's a positive, that one. So since we do not have a resistance, because we are supposed to have a resistance, it was supposed to be like this, remember? Need you to understand this. It was supposed to be a resistance plus JXL. Remember this. So we do not have the resistance, that's 0 plus JXL. So it will be just JXL. There's no resistance there. This is rectangular form. The same Z that we're having here for a purely inductive circuit, it can also be written as R, where we are going to have our R in this case, the angle of theta in polar form. But this we are not supposed to worry, because it's a purely inductive. We know that it must be exactly at positive 90 degrees. If it was a capacitive, it's going to be negative 90 degrees, negative 90 degrees. This one is a purely resistive there. There's nothing like, we do not have any imaginary part. We do understand that our Z is supposed to be given as R, but we do not have the plus JXL or what. So it will be plus 0 there. We do not have anything. So our Z is just equal to the resistance. So that's 25 plus J0 like this. The resistance is 25. But remember, this can be written in polar form. There is no angle there. So our Z is simply direct the 25 that we are given at an angle of 0 degrees. For a purely resistive, that one, we can simplify it a purely resistive. So remember, we need to understand this, because this is a parallel circuit where we do understand that if we have got a Z and another Z, let's say there we've got Z1 and this is Z2, we can calculate this in parallel. Where are you talking of ZR in this case, or this is ZL? Guys, we can calculate this in parallel. All right, so how are we going to have a parallel combination of two? Remember, we need the product over the sum. There are two there. So you're going to apply the product over the sum, meaning to say we are going to have the product of ZR and ZL and the sum of these two. That is what we need. So let's get rid now. ZR is just our resistance. It's fine as it is. We have it in both ways. We have it in rectangular form. We also have it in what? In polar form. Remember, I talked about the addition, subtraction, division, where it is important to apply both ways. So we need to simplify for the inductor. Let's work out our inductor. Remember, there is an inductance of 100 ohms, 100 millihenries, I mean. So we're going to need the reactance, which is XL, from the inductor. So from the inductor, let us calculate XL. Remember, guys, XL is 2 pi FL. You're also given this in your formula sheet. So that's 2 pi times the frequency. Our frequency there is given as a 50 hertz. So you're going to have 50 hertz times the inductance, which is 100 millihenries. So that is 100 times 10 to the exponent of -3. So that is going to give us the reactance. We are representing the reactance there. So this is going to be 2 pi times 50 times 100 times 10 to the exponent of -3. And that is going to be 10 pi, or as a decimal, that's 31,416. 31,416. All right. So that is our reactance of the inductor. So having now the formats that we had here, the rectangular form, meaning to say our Z was going to be given as ZL as 0. We do not have resistance. So it will be 0 plus JXL, our XL, which is 31,416. That is, we can have this in a rectangular form. What about in polar form? So in polar form, we're going to have our angle of 90. It's a purely inductive, that one. So don't even concentrate about the angle there. You know that the angle will be at 90 degrees. What you just need to calculate is your R. Remember, guys, how do you calculate? R is equal to the square root of A squared plus B squared. So it means R was going to be the square root of, this is our A, this is our B. So that's 0 squared plus 31,416 squared. So guys, if you're to simplify this, you're going to get the same 31, that you're seeing there, the 31,416. You're still going to have the same value if you simplify properly. So there, the purpose of having these two formats, even though the question is directing us specifically that our answer must be in polar form, as we are not supposed to consider that as we are calculating these. We need them both. Remember, as I said before, the product, because we are going to multiply these two, the product, it is best for you to have the product in what? In polar form. Addition in a rectangular form. So meaning to say whatever that we are going to have must be properly correspond. So our ZT was going to be ZR by ZL in polar form. What is our ZR? Our ZR for the resistor, that is 25, angle of 0. The angle is 0. There is nothing there. We do not have, it's directly at 0. Remember, current, resistance, and voltage, it will be at 0 there. Then ZL in polar form. We need our ZL in polar, that is 31,416. The angle being 90 degrees. We divide to what? The sum, addition, best in rectangular form. So we're going to take ZR in rectangular form. Remember, in rectangular form, that is 25 plus J0. I explained about this in our N4, if you still remember. And our ZL in rectangular form, that is plus 0 plus J 31,416. So that's it. That's it. We can simplify. Whatever that we are going to have here can be simplified. So thus we can obtain our ZT. Remember, why is it important for you to have the polar form for the multiplication? It is because you can multiply the numbers on their own, 25 and this on their own. Remember that. The angles you add. So it's going to be 25 times 31,416. You multiply, and for the angles you add, so it will be 0 plus 90 degrees. Guys, I talked about this on the introduction of the complex numbers. Make sure that you watch that. Rectangular form, I said it's easier for you to add in rectangular form since you can add the real terms together where we do not have a J. We do not have a J. So that's 25 plus a 0 there, which is 25. And we can add the imaginary terms where we have a J. So that's we're going to plus J0 plus this 31,4. So we are simply adding these two numbers that we are seeing there. 0 plus 31. So that will be J 31,416. We are still there. All right, we are still there. Let us simplify. We are still there. That is, we're going to have the product. Like I said, these two are under a product. So we need to multiply these two. Then we add these two. So if we are to multiply, that will be, okay, let me just save my calculator so that we be together here. That's 25 times 31,416. Already my calculator is fixed to 3 decimal places. That's why you see my answers to 3 decimal places. So it's going to be 785,4. All right. So we're going to have 785,4. That is comma 4. 0 there. Then the angle, you add 0 plus 90. That's 90 degrees. So this is what you were supposed to actually have obtained. This is what you could have obtained from the multiplication. Addition, we have already added. It's now in simplest form. But look, whatever that you're going to have here is under a division. And as you are talking of the division, it is best for you to apply division in polar form. So you are now forced to convert this to polar form. Since you are under a division, you have to convert this to polar form. We have to convert this to polar form. So guys, your polar form is not going to change. You are going to apply that part. So I'm just going to also wrap this in short. You're going to apply that part of your R being the square root of A squared plus B squared, your theta being arctan of B over A, where Z is going to be given as R angle of theta. Or like I said, you can just simply substitute this in place of this, wherever. We can just have your substitute direct. This is your A, this is your B. So meaning to say, there we are going to simply have the square root of A squared plus B squared, that is 25 squared, plus B squared, which is 31,416 squared. All right, then we're going to have arctan of B over A, that is this over this, 31,416 over A, which is 25. So that's it. So we're going to have our Z there. And I'm just going to show you also how to use a calculator just for the sake of these conversions. When you calculate, guys, some of these, they are not even necessary, guys. All right. So 25 squared plus 31,416 squared like this is going to be 40,149. 40,149. Then the angle arctan That's arctan there. There is an angle there. All right, so it's gonna be, oh guys, I did not even show the screen. I don't know if you are seeing my calculations, guys, here. The square root of this, so it's gonna be 40 comma. So there we've got arctan, so it's gonna be arctan 31,416, everything over 25 like this. Okay, so that will be 51,488. Okay, so we've got a 51,488 degrees. So this is it, guys. On your calculator, you can have this conversion direct. You can have this conversion. I'm going to talk about this. I'm coming back here, right? So I'm going to come back here. Let me write our answer. Remember this here, we were simplifying this to polar form. So that gave us 40,149, the angle being 51,488 degrees. All right, we are almost there. We just need to divide it. So remember, this was your conversion of the polar form, this rectangular form to polar form. You can simply use your calculator as it is, this part here, as it is. So it's going to be pol. You write this as it is, 25 separated by 31,416 as it is. On your calculator, it converts direct to the polar form. So this is what you're going to see. Okay, let me show you this. So this is where we have got the pole here on the plus. So it's going to be shift. Then you press this pole like this. So you press 25. Then you separate this by a comma, not this comma here, this dot here, but this one on this here or on this bracket here. There's a comma there. So it's shift. You press that. So that is the comma, not the dot. Okay, then 31,416. So this one you use the normal comma, which is comma 416. You can do this conversion. So as you can see, it gives us R, which is 40,149 and so on. And the theta, which is the angle, 51,488, as you can see. So you can also have that simplification. As you can see, we've got the same part as we had before, the 40,149 representing R and so on. All right, so that's it. In that case, let us finalize our answer. Remember, the purpose of division is that simplification is easier since we can simply divide the numbers on their own. Like I said on the introduction, you can divide these numbers on their own. That is obtaining the value of ZT. We're simply going to divide. So these two, let us divide these two here on our calculator. That is, you're simply going to divide those two. Then the angles, you subtract. Remember, guys, your polar form. So that is 785,4 divided to 40,149. So this was going to give us 19,562. So there we've got 19,562. 19,562. Okay, then the angles, you subtract this part of the angles. It's going to be subtract. You're dividing, you subtract. So it's 90 minus 51,488. So you're going to subtract the angles. 90 minus 51,488. So this was going to give us 38,512. So that's 38,512 degrees. That is, we have the total impedance of the circuit. Total impedance of the circuit. And remember, the unit's impedance is measured in what? In ohms. So I don't know if we are together on this part. You need these calculations. You are considering a parallel circuit. So product over sum. Okay. But the product best in polar form, sum in rectangular form. Division, again, polar form. We talked about this on the introduction. Let's hope we hear that introduction, guys. The total current on number 2, also in polar form. Everything here is needed in polar form. So how do you calculate the total current? Since we have got the total impedance, we can calculate the total current. Remember that total current is from the total voltage over the total impedance. So the voltage is there, 230 volts at an angle of what? The angle is going to be at 0 degrees. You divide to the total impedance already. This is a division, and I said division is best in polar form. So you're not going to have your Z in rectangular form unless there's a part where you need to add. So you need to take your Z as it is in polar form, 19,562, right? That's 19,562. Then the angle there, remember our angle was 38,512. 38,512 degrees. All right, let's hope, guys, our network is going to be able to help us to finish here. You see how it is presenting now. That's 38,512. So this is what we have. You can simply divide. All right, so you can simply divide here. Sorry for this, guys, 38 point. So let's divide. Remember, I talked about this, guys, division. You're going to divide these numbers on their own. All right, that is to obtain then the angles you subtract. So 230 divided to 19. So you're going to divide to 19,562. So that's 11. So there we're going to have 11,757. So that's 11,5 no, 757, sorry. That's 757. Then for the angles, definitely you're going to subtract. So that's 0 minus this. So it will be minus 38,512 degrees. So this is current. Remember that our current is measured in amps. So we are going to have our current in amps. So you must be careful in your simplification. What is it that you are to consider? All right. We have got the total current, this and that. Let me just also remove this part here. All right, no problem. Okay, let me just leave it. We might need this part, guys. All right, we might need this part. Let me just leave another part. There we need number 3, the current in the inductor. This is where our inductor is. Remember, the current in this case is different. This is a parallel circuit. The current that is going to be supplied, it will branch another current here. Another current branches there. It will branch the current. It will be different. What is it that we can now consider? It is the voltage, because the parallel circuit. So the voltage that we are seeing here is the same voltage that we are going to have here. We're going to have 230 volts. We are going to have also 230 volts across the coil, across the inductor. So having this, it can be an advantage to calculate the current. All right, guys, let me just remove this. I'm seeing that we do not have space now. It can be of advantage since we do understand that once there's a voltage and there's an impedance, remember there we've got the ZL of the inductor. We can calculate the current. So current being voltage over what? The inductor, the reactance, which is actually the impedance, because this is a purely inductive circuit. So remember, we say that is our reactance, which represents what? The impedance. So you're just going to write, but this VL is equal to VT in parallel. So meaning to say, we are simply using VT instead, which is our total voltage in parallel is the same. So that will be 230 at an angle of 0 degrees. Remember, I said that will be at an angle of 0 degrees. We have got our ZL division in polar form. So we are going to take our ZL in polar form. Remember our ZL here. It was 31,416. So that was 31,416 at an angle of what? Of 90 degrees. So that is it. We can divide just like what we had before, the numbers on their own, meaning to say the 230 and the 31 comma that we are given, the 31,416. So if you were to divide this properly, guys, you're going to obtain 7. That was going to give you 7,321. The angles subtract, division, subtract 0 minus 90, that's minus 90 degrees. So that's, we have got what? We have got the total current in this case. So this is the total, the current across the inductor. That will be the current across the inductor. So all this has to be known. All this has to be known. The current across the resistor, which is IR in this case, again, everything in polar form as per our instruction. We were going to calculate this because this is the same. Remember what I said in parallel, that VL is equal to VT. It is also the same as our VR. This is also as our VR. So meaning to say, we can calculate the current across the inductor in a parallel, across the resistor. The total voltage divided to the what? The impedance across the resistor. The total voltage 230 at an angle of 0 degrees. And what about the impedance that we have of the resistor? The resistive circuit, remember, in polar form, that gave us 25 angle of 0 degrees. So meaning to say, it is simply a matter of dividing, in this case, just like what we had before, the numbers divided on their own, that will give us 9,2. The angles, you subtract 0 minus 0, that's what? That's a 0. So that's we're going to have 9,2. That's the current across the resistor. So if you are to consider this, you are going to note that polar form, rectangular form is important. Whether the question is specifically aiming your answers to be in polar form. But there is a part where you are going to need the rectangular form. Are you talking of the addition? Because that addition must be in rectangular form. So there is no way that you can perform that without the rectangular form. You need the rectangular form in order for you to add. Division, you need the polar form in order for you to divide and multiply. So let's revise as much questions as we can. That is, it can help us. So that is, we can be given a condition like this. We're going to have more examples as we are moving on.